Hey guys, Coach Harris again. Just finished up with arithmetic sequences. Now we want to bridge over into geometric sequences, okay? As you're studying the difference between sequences or whether or not a list of numbers is a sequence or not, remember, arithmetic, it's either adding or subtracting a common difference. For geometrics, it's multiplying or dividing, or if you want to consider it like this, dividing is the same thing as multiplying by a fraction or a decimal. Okay, so let's look at the explicit form for a geometric sequence. So we got g sub n equals g sub 1 times the common ratio raised to the n minus 1. Okay, now we got the same form as we do the arithmetic sequence, but now I've got a g in front with a sub n. The notation there would suggest it's going to be geometric. Let's look at an example of one of these. So let's say I've got 1, 4, 16, 64, 2, 56. Oh, that's not a 2, that's a 5. Okay, and then so on and so forth like that. Okay, this is an example of a geometric sequence. Well, how do I know? Let's look at the relationship between the first two numbers. How do I go from 1 to 4? We want to think of it that way. Well, we could add 3, so we can check that right there because we were just doing arithmetic sequences. Well, if it's common difference, it's going to be the same between the first two and the second and third. So I add 3 here and I get 6. 4 plus 3 is not 16. So that's not an arithmetic sequence. By the way, that's how we know whether or not something's an arithmetic sequence or not. Take the first difference, apply it to the second, third, fourth, fifth differences. If it works out, it's arithmetic. In this case, it did not. So now we're going to try geometric. So I'm going to take the second number divided by the first. That gives me 4. Okay, so I'll multiply by 4 to go from the first one to the second. I'm going to take the third number, 16, divided by 4. Well, that gives me 4. So I multiply by 4. And then I recognize, okay, yeah, this is the same exact pattern over and over and over. That lets me know that this is a geometric sequence. Now, what do we call this number? We can't say difference. Okay, this R stands for common ratio. Okay, ratio would be a fraction, whatever we're going to multiply it by. In this case, the ratio is an integer. 4 divided by 1 or 4. Okay, so the common ratio is what we're talking about here. Now, how would I notate or how would I document the explicit form for this specific sequence? Well, notice g sub 1. We saw the sub 1 in the previous video when we were talking about arithmetic sequences. The a sub 1 meant the first number in the sequence. In this one, the g sub 1 means the first number in the sequence. So now if I'm going to write the explicit form, I've got g sub n equals the number 1. Go ahead and put that in parentheses, just keep it clean. All right, and then my common ratio is 4, and then raise it to the n minus 1. Now, do we have to write the 1 in front? Not necessarily, okay? But if you're just learning sequences, it's probably a good practice. Go ahead and put it in front, put parentheses around it. That way you can recognize that this g sub 1 right here actually is there and represented by that 1. Okay? Now, let me do another one that doesn't have the number 1 in the front just in case. So I've got, let's go negative 5, and then I've got positive 10, and then I've got negative 20, and then I got positive 40, and so on and so forth. Okay, is this geometric? Well, I'm going to take 10 divided by negative 5. That gives me negative 2. Negative 20 divided by positive 10, that gives me negative 2. And then I multiply this one. I see that this is a common ratio. All right, so the common ratio is negative 2. All right, g sub 1 is negative 5. Now I can write the explicit form. So g sub n equals negative 5 times negative 2 raised to the n minus 1. Well, how would we figure out what some obscure number in the sequence is? We could always multiply by negative 2 over and over and over and over. That's going to get old. Okay, so what will we do here? Let me say g sub 10, okay, is negative 5 times negative 2 raised to the 10. Remember, the 10 goes here. It's got to go here as well. All right, so how do we do this? I get negative 5 times negative 2 raised to the 9th. Okay, so let's see if I can do that real quick. 2 to the 5th is 32. 2 to the 6 is 64, 128, 256. So I'd say 512. Okay, so that's going to be negative 512 here. Negative times negative 512. So when I multiply those, I get 2,560, and it's going to be positive. So that is the 10th number in the sequence. Hopefully that helps you out. This is Geometric Sequences.